Okay, random AP question of the day. This one deals with a pot of tea that's cooling off. And the temperature is modeled by this differential equation H. And we're going to do a few things. A, we're going to approximate the rate. B, looks like we're going to integrate. And C, we're going to evaluate an integral. And D, we're going to do something else. You can read that. B, we're going to be using the trapezoid rules. So let's start with A, shall we? So this chart gives the temperature in degrees of this T. We do know that it's a differentiable function, and we're going to use the data to approximate the rate at which it's changing at T equals 3.5. So the rate is just the slope, and we don't know the function h of t, so we're going to have to approximate the slope at 3.5. So according to what we have at the table, at t equals 3.5, it falls between 2 and 5. So we're going to just approximate the rate it's changing in this little interval here. And since we don't have the function, we're going to have to do it with the slope. So we can say the derivative at 3.5, which is the exact rate at which it's cooling at that time, can be approximated by the slope between 2 and 5, which would be 52 minus 60 over 5 minus 2. So this is, the top is in degrees Celsius. Use the data to approximate the rate. It doesn't say to use, it doesn't say anything about units, so I'm not going to give units. The units would be in degrees Celsius per minute, but it didn't ask for it, so I'm not going to give it. I'm done. So that's it. Let's just go to B now. And remember, this is approximately negative 2.666, but you don't have to write that. I'm going to go to B here, since that didn't take too much time. So now they want us, using correct units, explain the meaning of 1 over 10 times the integral from 0 to 10 of h of t. So this is, if you remember average value, that's the average value of a function. So this is exactly what that is. This would be 1 over 10 minus 0 times the integral from 0 to 10 of h. So it determines the average value of the function h. In other words, it's calculating the average value of the temperature of the T over these first 10 minutes. So let's first answer that. That integral is the average temperature of the T It does say use units, so in degrees Celsius over these 10 minutes. Now we need to use a trapezoidal sum with 4 subintervals to estimate this. So a trapezoid, all we're going to do is create trapezoids, 4 trapezoids out of this data. So you can, what I would usually do on this is, let me bring this down here, is you can draw it, do it like a nice little sketch. You don't need to. If you're, as you practice this more, you're going to be better and better with it. and you won't need to draw it necessarily. You may be at that point now, but it doesn't hurt to draw it. So here's my t-axis. H of t is 66 here, 60 at 2, and it doesn't matter that the scale does not matter. So even if it is decreasing, it doesn't matter on my drawing. All I'm worried about is drawing these trapezoids. So here's the first one. Here's the second one. Here's the third one. And here's the fourth one. So now the approximate integral from 0 to 10 is all the areas of these trapezoids. So the bases are each of these. The heights are each of these. So I wouldn't do all this on the exam, but I want to make sure you're following this. Trapezoid 1 is height over 2, so 2 over 2, times the sum of the bases, 66 plus 60. Plus trapezoid 2 would be 3 over 2 times 60 plus 52, and so on. I'm going to run out of room, so let me move this over a little bit. Trapezoid 3 is from 5 to 9, so we have 4 over 2 times 52 plus 44. And finally, trapezoid 4 is 1 over 2 from 9 to 10, 44 plus 43. So that is the approximation of the integral from 0 to 10 using trapezoids. We need to find the average value. So it would be of h of t would be 1 over 10 times this. I'm pulling down. So there's the answer. Again, you do not have to simplify any of this. Let me make a little approximation. That's the answer. I believe this comes up to be 52.95, but you do not have to write that. So that was the first two questions, A and B. I'm going to stop this video because it's getting long and do C and D in separate videos.